Midway through one of the most productive years in recent space history, NASA's Exploration Systems Development Division is moving humans ever closer to deep space exploration. The Space Launch System, NASA's next-generation deep space launch vehicle, had an intense spring full of development and testing. Testing on the avionics system, responsible for controlling the Space Launch System's solid rocket boosters, began in April. The avionics system will ignite, steer, and jettison the two solid rocket boosters and will continue to undergo an extensive series of tests this summer. In May, structural tests on the SLS booster forward skirt proved it could withstand millions of pounds of launch stress during a series of ground tests. The SLS core stage will be powered by 4 RS-25 engines that are now undergoing preparation for test firing at the Stennis Space Center in Mississippi. Following initial testing, the engines will be integrated with the core stage, and the entire assembly will be tested on the B-2 test stand. Because the SLS core stage is 50% longer than the Saturn moon rocket stages, the mothballed B-2 test stand and the main derrick crane are currently being modified and upgraded to accommodate this enormous structural element and powerful main engines. Production on the core stage structure and propellant tanks continues at the Michoud Assembly Facility in Louisiana. 34 primary structure components and 20 rings have been welded to build the core stage propellant tanks, including 9 barrels and all the rings needed for SLS's first flight. A 5% scale model of the SLS was ignited to test how both low and high frequency sound waves will affect the rocket as it fires its solid rocket boosters and main engines on the launch pad prior to liftoff. These ongoing tests are collecting data from over 200 sensors to study the acoustic impact on the spacecraft and verify the design of its water-based sound suppression system. A major milestone in the effort to transform Kennedy Space Center into a multi-user spaceport was met when Ground Systems Development and Operations completed the initial design and technology phase of the preliminary design review. GSDO is modifying the spaceport's infrastructure to support several different spacecraft and rocket launch needs. Firing Room 4 at the Launch Control Center at Kennedy Space Center in Florida is being renovated into 4 separate launch areas to serve NASA and commercial users' needs. Designed to accommodate a multi-user spaceport, the new adaptable rooms can open up to give more space as needed by a customer's launch room parameters. Upgrades to the mobile launcher at Launch Complex 39 are underway, with significant progress toward advanced usability. GSDO is systematically modernizing the launcher to meet the increased needs of the more substantial Space Launch System. Upgrades include structural work, an improved sound suppression water system, a redesigned exhaust opening, new data connectivity to the Launch Control Center, and updates to the power, air condition, and fire alarm systems. After the Exploration Flight Test 1 mission is complete and the capsule lands in the Pacific Ocean, the Ground Systems Development and Operations and Orion programs and the U.S. Navy will retrieve the capsule and ship it back to Florida for reuse. The return process requires a series of pre-transportation operations, which were successfully tested in May. Workers practiced assembling a transportation fixture that will be used to move future Orion crew modules across the country. The newly renovated Flight Control Room at the Johnson Space Center in Houston played host to members of the media and top NASA officials in April. The White Flight Control Room will support the Orion spacecraft during NASA's deep space exploration missions. In May, the room was used in a joint integration simulation, along with a team at the Kennedy Space Center in Florida. The two teams simulated the pre-launch and in-orbit phases of Orion's mission and solved real-time problems, acting as the eyes and ears of the uncrewed spacecraft. The rigorous testing on Orion's parachute system continued in April and June, proving the parachutes are capable of surviving potential failures during both re-entry and launch abort scenarios. The first test simulated an abort scenario by dropping the capsule from a height of 13,000 feet and releasing the main parachutes before the drogue parachute could deploy or the vehicle could straighten itself out. The second test pulled the capsule from the C-17 airplane at an altitude of 35,000 feet, with one of the main parachutes intentionally rigged to skip a crucial phase in the unfurling process. Both tests demonstrated the parachute system can tolerate unexpected failures and still carry the capsule safely to the ground. After 2 years of intense production and testing, Orion's massive heat shield was successfully attached to the crew module in Kennedy Space Center's Operations and Checkout facility. The 16.5-foot wide ablative shield will protect the capsule from re-entry temperatures of up to 4,000 degrees Fahrenheit. A center of gravity test confirmed that all of the ballast was properly installed in the crew module. The test validated the Orion team's computer models used to calculate the amount and location of ballast needed to properly balance the crew module. With the heat shield securely attached to the capsule, the crew module was then stacked on top of the service module in June. The stacked modules will undergo electrical, avionic, and radio frequency tests to prepare for the Exploration Flight Test 1 in December. In May, astronauts at the Neutral Buoyancy Laboratory in Houston trained underwater in newly modified spacesuits to work through simulated operations for NASA's asteroid retrieval mission. A month later, a naval team worked with Orion recovery specialists to train for a set of procedures to safely retrieve the capsule and forward bay cover. As Exploration Systems development closes in on December's launch of Exploration Flight Test 1, NASA centers nationwide stride toward the Moon, Mars, and beyond.